back and there in the front. A flash right here in the front. See, now lava is going above the ice block and making all of these tiny little bubbles. But have you ever seen valleys here? This is what happens when lava flows over the edge of a volcano, and it just creates these very thin filaments of lava. They are really rare in nature, and we call them after Pele, the goddess of volcanoes. But here in Iceland, we don't have a goddess of volcanoes, so we call them Nornahal. But you want to see what happens if I throw an ice block on top of the lava instead? The lava is on fire. The lava is smoking. But let's see what happens now. See how different it is from when lava was flowing above the ice block. Here it's just creating bubbles, but it's way much slower. It kind of looks like the lava is breathing in the front because all my ice is just being turned into vapor, and that vapor is trying to escape the lava. But can you see how in this area my lava is already turning black? Because the top part is solidifying, but here below it is still extremely molten. I can't really do a pellets here like I was doing before, but I can still play with it. Here, my lava is still like very squishy, but it's not like this area where it's so solidified. And because it is so squishy, be careful of the flash over there. I should be able to do this. And here, I do indeed still have very molten lava. I can't play with it because it's so shiny, because the temperature here in this area is still very high. All of my yellow lava should be over 1000 degrees, while my orange lava and red lava should still be over 600 degrees. Because after 600, my lava just stops emitting visible light and it stops glowing. And the least shiny it is, the harder time I will have to play with it, because my lava is becoming more viscous. And viscosity is a property of the lava that depends on temperature. So the higher the temperature, the less viscous my lava. And viscosity is actually something that is very important when it comes to how explosive an eruption can be. But you can notice the difference in temperature of the part over there in the puddle and over here. Over here, it looks pretty solidified. That's because my lava is a very good isolator of heat. And because it's so good at isolating heat, it creates this outside crust very quickly. In this case, the crust is on top of the lava and below the lava. So I can actually make it and bend it as I want. The outside part, it is still extremely solidified, but the middle, if I was to poke a hole on it, I should still be able to get some molten lava out of it. And actually, if I was to drain all the lava that is still in this tunnel, people in the sides, I think you can see all of my lava escaping from the hole that I did. I should actually create some sort of empty pipe. And actually, that's how you do lava tunnels in real life. Because here, I've stopped pouring down lava. But in an actual eruption, we would have a continuous pour of lava for a really, really long time. And in those cases, because lava is so good at isolated heat, you'll start traveling beneath the parts that are the coldest. So the first part of an eruption, you start to form a lot of out of shelves and a lot of like darker areas. And then all the lava will start traveling beneath them and create rivers, tunnels, and a ton of complicated structures. That's why the lava is actually able to travel so far. But now I want you to pay attention to the sound that the lava is doing. I'm also going to put the lights on a bit so you can see how the texture is changing. This sound is quite relaxing, right? It sounds like a fireplace. I've also been told that it sounds like Rice Krispies in milk. It's nice, right? This is the sound of my lava cooling down. Because when my lava cools down, it shrinks. It wants to occupy the least amount of space as possible. And right now, the sound is very nice and relaxing. But throughout the show, because it's sitting on top of the metal, it'll start to make a lot more noise. And just ignore that part. But I'm going to put these crates on that will make the sound appear even larger than what it is, just because I don't want to have lava on my face as it shrinks. It's not really for you guys, it's more for me. It's not really an enjoyable experience, let me know. But let's go back to our lava. Remember when I was saying that all black lava should be below 600 and all glowy lava should be above 600. Let's test this black part. So this black part that is very thin, it's at 669 degrees Celsius or 696 Fahrenheit. While my glowy part, it's at 631 or 1100 Fahrenheit. Let's see if that actually makes a difference when I throw paper on it. See, my job is just like making cool stuff with a lava. So the part that is over 600, you'll catch everything on fire very quickly. But the rest, it will still burn everything. And that's actually how an eruption acts. Because if you see an active eruption, unless it's the first hours, you won't really see that much molten lava. You will see a lot of dark rock. But even that dark rock can still burn everything in this path. And we are expecting a new eruption. Maybe in a few days, maybe today, who knows. We have been expecting it for the last 2 weeks. So if you do feel like going on a walk around the new volcano, and if you think that it looks like a normal rock, it is smoking, but it shouldn't be that warm, right? I do have to tell you that it is going to be that warm. So if you do go there on a walk, the thing that is going to happen is that because these rocks are quite new, they are quite breakable. And because the lava is so good at isolating heat, what can happen is that you might feel like you are pretty safe going into a very solidified lava field. But look what could be happening beneath it. The bottom part is still completely molten. I'm going to go on the other side. So here you can really see how my lava is trying to keep all the heat in. But now, because my lava is losing almost all the energy and all of the light that is coming out of it, I'm going to put the lights on even more And now I want you to pay attention to a sound that the lava is going to make again. It sounds like glass, right? And why is that? Because this is glass. This is volcanic glass. Does anyone know a name of a volcanic glass? Obsidian. You all think this is obsidian? It's not. It's just a boring cousin of obsidian. It just comes from a different type of lava. Obsidian comes from rhyolite lava, and here I have basaltic lava. Basaltic lava just has less silica than rhyolite lava. And silica in lava acts like the glue ingredient. So the more silica you have, usually the more viscous your lava is going to be. So usually in basaltic lavas, because you don't have as much silica, you don't have explosive eruptions. And in Iceland, you usually see just like runny, flowy lavas. That's because they are mostly made of basaltic lavas. And in this case, I'm not making obsidian, I'm making tachylite, which doesn't sound as cool. So if you want to say to people that you saw obsidian, I'm not there to say otherwise. But like you can see, unlike obsidian that used to be used as weapons, this one does break very easily. But because I was able to break it, I'm going to show you how it does look on the inside. You saw how black it already looked, but here it's still extremely red on the inside. It's losing all the heat and energy very quickly because it's cooling down extremely quickly. That's why I'm making glass in the first place. Because when lava cools down, all the elements that are in the lava, they want to form bonds as quickly as possible. And usually when you have really complex bonds, that's when you make crystals. And when you put a bunch of crystals or minerals together, that's when you form rocks. And in this case, this is a rock, but it's a rock without minerals because neither of the elements have time to join and form bonds. That's why it's see-through, because there is nothing there to block the light passing. And it's only black and not like a normal window because it has iron in this composition. In your windows in your houses, you don't have as much iron. You have mostly silica. And because you have so much silica, the glasses don't break when you tap, which I think is good. But in this case, this is extremely breakable. I'm not tapping this very hard, just because I do not want to make like a catapult situation. I don't think balcony would mind, but maybe the front row would. I'm trying to avoid that. But I can continue on rambling about lava for a very long time, but I would much rather tell you about something that you want to know. So I'm going to put the lights on a bit so I can see what's sleeping. And also, this is the time for you guys to ask me questions if you do have them. The little one doesn't count. But yeah, any questions, guys?
So what increases the silica then? Where does the silica come from?
Silica comes from the earth. Every type of lava has different contents of silica.
So more composite volcanoes?
It really depends on the area of the planet. Here you mostly have basaltic lava because you have a rift here. So the lava doesn't come from it comes from a deeper place on the earth than just one that is more superficial. But also every lava is always different. Even from the 2021 eruption, which was one of the mostly closely studied eruptions, they were able to tell for the first time basically that every time that they had a new pulse, because when lava comes out of a volcano, it's not like a continuous pour. It usually comes in different bursts. So each pulse that would come out would have different compositions, which means that even though the lava is supposed to be stored in the same magmatic chamber, it actually doesn't come from the same places. And even in the same magmatic chamber coming from the same origin, you can have different compositions that don't really mix. And that's really interesting because it just tells you the full story where your lava started to form until it came to the surface. Any other questions? You have a question?
Yes. Are there similarities to Tacolite and obsidian?
Can you ask me that again?
Are there similarities than Tacolite and obsidian?
Yeah. So my Taculite and my obsidian, they are similar because they are both glasses. And they didn't take long to cool down. Because actually my Taculite is closer to this basaltic stone just because they are the same rock. They just took different periods to cool down. It's like when you are trying to bake a cake. If you bake a cake for 5 minutes, you will have a very liquid cake. But if you leave it in the oven for like 30 minutes, you have a fluffy cake, right?
Yes.
And this is the same case. My volcanic glass is like my liquid cake. Doesn't take long. If you hold it in your hands, it will fall apart, right? Here, you have a solid just because you have silica. And here, like I was saying, silica is the glue ingredient of the lava. So it still acts like a solid just because it has silica. It's like sugar in honey. It makes it stronger. Yeah. Any other questions? Yeah?
So as lava's coming out onto the earth, it's more just being made constantly in the earth.
Yeah, it's being melted. Technically, lava starts to melt when it reaches the melting point. So around 1,500 or something. So usually you need something to actually make the earth melt to form lava. Because you have a lot of pressure the deeper that you go, and that pressure doesn't allow the lava to melt. And the lava actually comes just from the earth itself. So like the mantle, it's the mantle itself that melts to have your lava. And you need some sort of trigger, like maybe water, maybe the convection waves that you maybe taught in school. That's usually what triggers the lava to actually be able to be melted. So your mantle will stop being just some sort of solid and it starts being liquid. Any more questions? Yeah?
Do you take this all back to become the next lava show?
What do you do with this after we finish with the show? Yes, we are going to take it back. We have been recycling the same lava ever since we started here in 2022. Because like you can see, obviously this lava is still incredibly hot. After this show is over, because we have another one in 2 hours, we are going to have to use very sophisticated equipment to take this off. It's just a pitchfork and a bucket. Like I've been breaking this like sort of carefully. The lava melters can come after everyone is gone and just absolutely smash this into pieces. Pick it up, put it in a bucket still warm, and put it back in the oven. Because I'm not changing anything in the chemistry of the lava, I'm just like changing the state of matter. So between solid to liquid, liquid to solid, and over again. I could do this forever. But we do take little pieces out every once in a while for the gift shop and to make jewelry. If we didn't do that, we could technically recycle the same type of lava until we would close down the lava show. But they call this like an infinity soup. You keep adding to it, you keep removing stuff. It's the same lava, but after a while it's not really. But we say it's the same lava that we've been recycling for 2 years. More questions?
You used the word Pele. What was that used to describe?
Pele is when you make this, let me see if some of them still survived. So Pele is when you make these very thin pieces of lava, and they are really thin, usually thinner than this, and it's just called after Pele, the goddess of volcanoes. And usually these tiny pieces don't really survive an eruption just because I can break them with my hands. So imagine with wind, rain, snow, everything else around actually does to this in an actual eruption, just gets blown off, unless it's like gets blown off by wind and stays in a like little corner. They will survive, but usually you don't find them. Here we make them every day. Yeah. Any other questions?
Yeah. What sort of heat do you use to melt it? Do you use a gas oven?
So we use a furnace that was adapted from the ones in the metal industry, and we use methane. just because we have our recycling center over there, and all the like organic waste from the city naturally produces methane. So we use that as like a more natural energy source. Because here in Iceland, we do like to say that we run on 99% of geothermal energy, but actually to use geothermal energy and just normal electricity to heat up the furnace for one show, we would be spending like 400 houses worth of electricity just for one show, which is not very sustainable. So that's why we use methane instead. Any more questions? No? I see one hand. Do you want to ask me a question or? Can you say that louder? How do I become a lava scientist? You go to school, you study geology, you don't learn much about volcanoes, then you do a master's where you learn a bit about volcanoes, and then you pick a thesis where you can learn finally about volcanoes. Yeah, exactly. It's a long way, but it's cool. Any other questions? So if you don't have any more questions, I will just leave you with my last fun fact about lava. So have you ever seen one movie where someone just falls dramatically into lava and like slowly drowns? Yeah, like Lord of the Rings and stuff like that. I do have to tell you that's a lie. It's literally impossible. So now you can be that annoying person whenever you are seeing a movie that can just start to like, there's no possible every time that something like that happens. Just because my lava, it's 3 times denser than water. You guys are mostly made of water. So if you were to fall into lava, you would kind of like splash on top of it. You would never sink into it. So I don't know what your plans are. If you are planning on going to the eruption site and an eruption does begin, if you were to fall into the lava itself, you'll be good, guys. You will never sink into it. If you can't swim, you're fine. You might have a few other problems, but at least you're never drowning. I hope that's a bit reassurance for you guys. Well, yeah, with this, I really hope that you've enjoyed the show. If you did, we always appreciate reviews on Google or TripAdvisor. If you did enjoy it, my name was Patricia. If you didn't, my name was Gabor, the Lava Melter. Okay? So yeah, thank you so much for coming.